Hello people, how y'all doing? So now we're gonna go through oscillators and the clock. We're gonna start with the clock because it's a very simple concept, extremely simple. So the clock, well, first actually I gotta explain the CPU, the RAM, and the hard drive until we get to the clock. And so usually you'll have something called a CPU, and this is the central processor unit, CPU. Your CPU is basically the brain. Okay, this is the brain of the computer. All right, and what it basically does is the arithmetic basically. And so this is what it does, all the calculations, the 1 plus 0 1, let's say. That's what it does. All right. And so where does it get its instructions from? So let's say you want to tell the CPU to do some type of arithmetic. Where does that get it from? It gets it from something that looks long. I know you guys are thinking about. It's called the RAM. All right. And I believe this is called random access memory. Okay. And usually you'll have this in laptops. They can come in 4 gigabytes or 8 gigabytes. The one I have in my computer is actually 16 gigabytes, and I have 2 slots of them. So I have 32. And so that's how they usually are, and they hold, they have some memory, and they hold some numbers. All right. And these are actually usually 8-bit numbers. So 0, 0, 1, 1, 1, 1, 0, 1. All right, let's say it's something like that. And there's also, you have the hard drive. The hard drive is usually some box like this. Nowadays, they look just like that. They're called SSDs. But hard drives usually are like, they have a disk inside, and these are called like hard drive. And these have memory, sometimes 1 terabyte, sometimes 100 gigabytes. It depends whatever hard drive you have. And so the way it works is, let's say this is where you store your program. All right, program as in like a game, your Microsoft Word, your browser, Chrome, Safari, whatever you use, your pictures. They go on the hard drive. If you want to access them, what happens is your RAM goes to the hard drive, grabs whatever it needs. Let's say your game is 50 gigabytes. That's your game. But in order to run the game, you don't actually need all the 50 gigabytes. It depends what you're doing in the game. And so your RAM will grab whatever memory it needs, like let's say 16 gigabytes, and it will store it here. And this is fast memory. Your hard drive stores a lot, so it stores big memory, but it's slow. The RAM gets a lot, little memory, but it's fast. What I mean by fast is when you want to get some address from it, you can get it really fast. All right. And so what happens is this connects to the hard drive, and this connects to the CPU. Okay. And so what the CPU does, and there's the clock. And this clock is actually not an outside component. This clock is usually inside your CPU. It's a very small component. And what it does is, obviously, your CPU will take some register from the RAM, and it will do the arithmetic it needs to do on it. So let's say you have register A, you have register B, and so what happens is you'll take this section and you'll plug it into A, your CPU will grab it, then it will take the next one, right? And it will store it in B, and then it does some arithmetic, let's say add A and B, so we'll add A and B, and then store the addition, so let's say it adds like 11 plus 10, and you get 21. It will store that in your A, let's say, and obviously it does this so fast. It does it a couple million times a second. So the way your CPU is measured is in hertz. Now, what is these hertz? This is frequency. Now, frequency is a period. So let's say it does 15 additions, right? Additions per second. So every second it does 15 additions, like 10 plus 10, 20 plus 20, whatever. This is your frequency. It's how frequent it does the addition. But obviously, like I said, it does millions of these. And so the CPU has millions of registers that does these additions. Something has to control and sync them all, and that's the clock. The clock basically, it ticks and it tells it, okay, now this register go. Now this register go. And it tells it like it synchronizes everything. So like the RAM doesn't grab so much memory when the CPU is still lacking behind. Or the CPU is lacking behind and the RAM just wants to shove shit in. Right? And so that's basically a clock, and it's measured in, well, nowadays we have gigahertz. For example, my CPU is I believe rated at 3.9 gigahertz. What this means is I believe it does like 3.9 million calculations per second, and so it's crazy amounts. And so that's basically a clock. All right, now that you understood what the clock is, we're gonna go over latches. And well, not latch is, we have one latch to talk about. And this is the SR latch. Right? Now, actually, if I take this whole thing and make it a lot bigger, that'd be nice. All right. Now, the SR latch, what it is, it stores memory, stores 1-bit memory. And what I mean by store, this only stores only when has electricity. So as soon as you turn this off, your memory is gone. It doesn't store it. This is the very basic one that while it's on, it will hold a state, either a 0 or 1. And then when you turn it off, it just goes away. Okay? And so this is when it first started, and it's called an SR latch. And the way it works is here. This is called a reset. And this is called a set. All right? And the way this works, here you have a NAND. A NOR actually. It's very simple logic, and it is coming on the exam, so make sure you know what this is. So NOR is if I have A, B input, and then the output of a NOR. If I have 0, 0 gives me 1. If I have 0, 1, it gives me 0. If I have 1, 0, it gives me 0. And if I have 1, 1, it gives me 0. All right? And so now, for a SR latch, all right, the rules are, well, we'll actually fill it as we go. So we have a R, we have an S, we have a Q, and we have a Q bar. All right? And so the way this works is the first, usually when you first turn it on, this is 0, this is 0, right? This becomes 1, and this becomes 0. Okay, now how does this work? Is, well, when you have a 0, right? So a 0 going through here. Here, there's a 0. So actually, I'm going to use red to highlight things. So here, we have 0 going through. Here, we have a 0. So that goes through here, right? And here we have a 0. 0 and 0 gives me 1. And so that gets, oops, what happened? There we go. And that gets me a 1. Now, when 1 passes through here, 0 and 1 is 0, right? 0 and 1 is 0. And so when that happens, I get a 0. And as you can see, when R is 0, and when S is 0, my Q is 0, and my Q bar is 1. Now, what about if my S, so what about if my S is 1? Then what happens? Well, let's restart. Oops. Let's restart here. Okay. So now if I had 1 here, oh no. All right. If I had 1 here and I had 0 here, I don't know what happened to my reset or my set. All right. And so when I have 1 here, obviously this was a 0 and this was a 1 previously. But when this 0 is going through here, 1 and 0 is, well, 0, right? 1 and 0 is 0. And so now 0 goes through here. 0 and 0 gives you 1. And so this turns into a 1. And so as you can see now, my Q is 1 and my Q bar is 0. And you see these always opposite each other. Always opposite. So when both of them are 0, it holds the old state. So if before this was a 1, it will stay at 1. If it was at 0, it will stay at 0. So watch, you know how this is a 1 right now? What I'm going to do is I'm going to turn this back to 0. Right? And so what will happen is this will be 0, right? And then here, this will bring in 1. 1 and 0 is 0. 0 and 0 is 1. You see, it didn't change. And so the set will only set it to 1. But when both of them are 0, this will always stay the same as what it was before. It won't change. But when I set my set to 1, then it will change the output. All right? And so now, what happens if I press both these buttons? What if in both buttons, I press them? So I get 1 and 1. And so before I had 1, 0. And so when I have 1, 1, what happens is this 1 goes through here, and this one goes through here. That gets a 0, right? Then the 0 goes through here, and I get 1, 0. 1, 0 is 0, right? Now these are the same, but remember how we said always opposite? And so when both of them are 1, when you have 1, 1, what you'll get is 0, 0, and this is called undefined. It's not allowed. All right? And so remember this. When you do reset, when reset is 1, okay, so here I'll actually write it here in simple terms. 1, reset equals 1, you output 0. You just go back to the original. When set equals 1, out, you set it to 1, you output 1. When both equal 1, then you get undefined, right? And when both equal 0, nothing happens basically, right? It holds old state, so it just nothing changes. And that is our SR latch. It's the most basic form of memory, and it only works when the computer is on.